Welcome to the session on vectors, modelling with vectors. The objectives for this session are to use vectors to solve problems in context. Vector quantities have both magnitude and direction. Examples include velocity, displacement, and force. The magnitude of a vector is a scalar quantity, and the distance between a point A and a point B is represented as mod AB. In vector notation, the unit vector j represents north and the unit vector I represents east, as shown in the diagram. Let's now take a look at an example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve example 1a first. A car travels 4 miles due west from a point O to A, and then 5 miles due south from A to B. Find the total distance travelled. So let's solve this. We have that the total distance travelled is equal to 4 miles because it's first travelling 4 miles due west, and then 5 miles because the car is travelling 5 miles due south, which gives us a total of 9 miles. Now for part B. We are required to find the position vector of B relative to O. So here's north. As you can see, the car travels 4 miles due west and 5 miles due south, and this is represented in the diagram. So solving this gives us that the position vector of B relative to O is equal to minus 4i minus 5j. So here's minus 4i. It's travelling in the negative x direction. And here's negative 5j. The car is travelling in the negative y direction. Now let's solve example 1c. We are required to find the bearing of B from O. Let's join O to B and then solve. We're first going to look at the anti-clockwise angle NOB. This is equal to 90 degrees plus tan inverse 5 over 4. This comes from the formula tan theta equals opposite over hypotenuse. And we've simply inversed in order to find theta. And theta is the angle which has been highlighted in red. So our angle NOB is equal to 90 degrees plus 53.1 degrees. And of course 53.1 degrees is tan inverse 5 over 4. And adding the two together gives 143.1 degrees. So the anti-clockwise angle NOB equals 143.1 degrees. However, we are actually required to find the clockwise angle NOB. And this is equal to 360 degrees minus 143.1 degrees, which is equal to 216.9 degrees. Here's a summary of the results for example 1. Now let's have a go at another example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve this. Let's begin by drawing a diagram first. We have that a schoolboy leaves home, point O, and cycles 20 kilometers on a bearing of 150 degrees to reach a point A. So here's north, and here's the journey the boy starts to take. He's traveling 20 kilometers on a bearing of 150 degrees to reach a point A. From A, he cycles 8 kilometers on a bearing of 230 degrees to school at point B. And again, this is denoted in the diagram. Finally, he returns from point B, cycling through a field to arrive home directly, as shown. In 2 Part A, we are required to find the position vector of A relative to O. So let's solve this. First, form a triangle around OA, as shown. We've positioned this separately so that we can do our calculations on this triangle. Now the angle alpha is 150 degrees minus 90 degrees because we're taking away that highlighted angle at the top, which is 90 degrees. Therefore, alpha is equal to 60 degrees. And hence, OA in position vector form is equal to 20 cos 60 I, which is the length highlighted, minus 20 sine 60 j, which is this length highlighted here. And therefore, we have that OA is equal to 10I minus 17.3 j. Now let's solve example 2b. We are required to find the distance and bearing of B from O. Let's solve this. From the cosine rule, we have that the length OB squared, or A squared, equals B squared plus C squared minus 2BC cos A. So let's plug in all the values. Mod OB is A because it's opposite the angle capital A. Little b is the side length opposite angle B and is equal to 20 kilometers and is plugged into the formula. And now think of the origin, or O, as angle capital C. The side length little c is opposite capital C, and that's 8 kilometers. So we plug that into the formula too. The angle A is equal to 100 degrees. And so tidying up and calculating gives us that the length OB squared is equal to 415.567. And therefore, if we square root, we obtain that the length OB is equal to 20.4 kilometers. Now let's try and find the bearing. The sine rule states that sine C over C equals sine A over A. Therefore, plugging in the values gives us sine theta, as shown in the diagram, over 8 is equal to sine 100 over 20.4. And so tidying up and rearranging gives us sine theta equals 8 times sine 100 over 20.4, which is equal to 0.386. And finally, if we inverse sine, we obtain theta equals 22.7 degrees. And therefore the bearing is equal to 150 degrees plus 22.7 degrees, as you can see from the diagram, which is equal to 172.7 degrees, as shown. Finally, for 2 part C, we are required to find the position vector of B relative to O. So let's solve this. So here's the relevant part of the diagram. We can find the I direction of the vector OB by using the cos ratio, which is cos theta equals adjacent over hypotenuse. And we can find the J direction of the vector OB by using the formula sine theta equals opposite over hypotenuse and plugging in the values. So we have that the vector OB is equal to 20.4 cos 82.7 degrees I plus 20.4 sine 82.7 degrees J, which is in turn equal to 2.6 I plus 20.2 J. Here we've used one formula. Here's theta, here's the adjacent, and here's the hypotenuse. And here for the J direction, we've used the sine formula, and here we have theta, here we have the opposite, and here we have the hypotenuse. And here's our solution. This brings us to the end of this session. If you have understood its contents, you should be able to use vectors to solve problems in context. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.